Me?
Oh, that's
Okay. So who has used Mgwt before? Okay, then I'm about to hold the right talk. So this is not going to go into technical details on Mgwt and how it works internally. It's just going to be why it's a good idea to build something for mobile with Gwt. I'm going to introduce you to PhoneGap. I'm not going to introduce you to Gwt, obviously. Then we talk a little bit about Gwt PhoneGap and what that does, and then about Mgwt. You know who I am and what I do. And this talk is somewhat different. I got like 45 minutes, so I figured 25 slides. Whoa.
Not worry, we'll go.
Wrong one? Ah.
It's on
Slight
this
delay.
one, isn't it?
It's a slight delay, I would guess.
Yeah, maybe it's stuck. Just try to see what happens.
Let's see.
Action still going.
That way.
Whoa.
Okay, that's working. Are you sharing?
I'm sharing. So I'm guessing I got like 45 minutes, and I should be safe with 25 slides, but I'm going to do this with 274 slides. So
You seriously have 275 slides?
yeah, I do. But the problem is this is really lagging really bad, so this is not going to work. Let's see. So I've been a web developer for a really long time. That found this is like seriously like 5 seconds.
Well, you know. Network. So pipeline.
Yeah, so I probably can't get through all the slides. But I've been a web developer for a really long time. That founded one really deep belief in me, and that is mobile applications have to die. That's a quite strange statement to make, but because currently mobile applications are doing quite well. Lots of people are making lots of money out of mobile applications. But let me get to the point. I'll actually skip through some of those if we're going to have so much trouble displaying them. Let's see. So I've been doing a lot of hardware in my career, and I've been doing a lot of software. And so this means 2007 has been a really great year for me because I could carry all the software I was doing with me in my pocket. And if you're doing that, your phone starts to look like this. Cluttered full of software, and you're not going to be able to find anything there anymore. And do you know how many applications you could actually take with you on a phone? It has been 144 when the SDK got released. It took me like 2 or 3 weeks to actually reach that, and I couldn't put any more applications on my iPhone. Then Apple went ahead and actually did something called the folder concept. And with that, you can actually take 1,684 applications on your iPhone. And at first I thought, all right, that's a really great idea because now I can take all the applications with me that I need. But on second thought, I wasn't able to find anything anymore. So, and if you think back at the web, we've seen the same thing happening there. A long time ago, there's been a company called Yahoo. And what they basically did, they had a bunch of editors sitting around, surfing through the web, and put that into an index. And then users could actually search for that index. And along came Google and improved that a lot by 2 main things. The first thing were they actually put in some servers to do the job. And the other thing was they actually had a good system of linking between the pages, so your search query was actually had results that were really relevant to you. And that ended up with lots of happy users. And if you take a look today at app stores, they basically do the same thing that Yahoo did like 10 years ago. They put a lot of content in there, but they don't really help you to find the content that's relevant to you. And this is why I think app stores are basically, they look like this. There's useful stuff in there, but it's really hard to find, and they don't really help you out much. It's going to get really worse over time because soon normal people that don't do so much software on their phones are actually going to be hit by this. Because we're going to pay for our coffee with our phones. We're going to pay for our shopping with our phones. Basically everything around payment revolves to phones. And if our expectations are actually going to change if we come to a bus stop. Today, in Germany, you actually have to enter the name of the public transport company into the App Store, install the app to find out when the next bus is coming. Just put a damn QR code on there so you can just see that with a mobile web application. And then there are web pages like this. You take your phone, go to a website, and they actually prompt you to install an application. You could be seeing the content right away.
Have you seen, there's a Tumblr site recently about, basically it's just all these pages.
Okay, that's great. So you could be seeing the page right away or install an application for a small web page, which then have to constantly update. How would that work out? Like having hundreds of small applications on your phone, which you then update every day, every 2 days? No, that wouldn't work out. You get a good idea of what's about to happen if you talk to people that are actually doing hardware. And basically they're telling you that CPUs are going to drop so much in cost that we can afford to put a CPU in almost anything. So this is going to be pretty much the same thing we've seen with the web in the late 90s, that the number of web pages is simply going to explode. So the number of possibilities of the things you want to do with your phone is just going to increase. It's going to increase to a point where you can't really do that with applications anymore. So let's recap. We've seen that on the web before. Certainly there's going to be some applications that you want to have on your phone, but most of the applications are actually better off as being a web application. And, well, if you want to do that today, there's one really good way of doing it, and that's PhoneGap. And I don't want to introduce you technically to PhoneGap right now. I just want to introduce you to the problem PhoneGap tries to solve. And it basically goes like this. If you want to write software for different telephones, you have to deal with those different vendors, you have to deal with those different OSs, and with those different languages or APIs. That's a lot of investment to do. If you've done that, you're going to notice that a half year later it starts to look like this, and then like this, and then like this. And as a web developer, I think of this as a really, really big fail. We already have a really good way of bringing software onto almost any platform, and of course that's just called the web. It's really hard to do with 5 seconds delay. And that is what PhoneGap is actually trying to do, bring the web to every device out there. So let's compare native development for different mobile platforms to actual web development. And the rhythm basically goes like this. If you're doing native development, you're going to have high development times and high costs because you're going to do things all over again. So you don't get any portability. Things you're doing for Android, you have to do them all over again for iOS. Of course, you're getting good performance. You're getting to use all the native cool APIs, and you can be in any app store. On the other hand, if you're doing web development, there are lots of good web developers already out there, so you're getting low cost, you're getting high portability. Things you're doing for the Android browser most probably run on an iPhone just fine. You're getting good performance if you know what you're doing inside a mobile browser. That's pretty important there. So some people are thinking you're actually getting bad performance if you're doing HTML5 applications. That's not true. If you don't know how a browser internally works and how it works on a mobile phone, then you get bad performance. So, but you can't access any native APIs, and you can't certainly be in any app store. Yeah, please.
So, like, just want to ask if you know more about like why Facebook moved, because they had HTML-based application before, and then
Because Daniel
so they couldn't.
Hey, I got like a polite answer,
Yeah.
and I got like a brutal one because they don't have good engineers that actually did that.
I think we can, because
Censure-
you're probably
call
like
it-
low on time, but like I think Colin can probably talk about what Cinch did with their.
Yeah, I can actually fill that in pretty good. So what Censure did is
Yeah.
they used their framework and exactly built the Facebook timeline where the Facebook engineers said it wouldn't be possible on a device. So they actually did that using the Censure framework within 2 or 3 weeks. Colin can probably fill in details.
Sure, yeah.
It worked really smoothly.
They use web workers as well to improve the performance.
Yeah, they did some nifty tricks, but okay. There's actually one really big problem to the Facebook application. You need to know how much memory you're consuming on a mobile device, and you can't get any access to that. That's the only thing. But they did like they pulled in all data from their Graph API, and they throw away 90% of that. That was the first thing Censure actually did. They put in a proxy in between and said, okay, we're not going to put all that data back to the device. So the device actually doesn't have to parse that. And actually, the HTML5 version Sencha build is faster than a native version Facebook has built. So
Even a native version still has some
I
web
read
views in it.
the article as well.
So I think that those were mainly, they were web developers and they were thinking of the browser of something you throw HTML at. They didn't look actually to how to profile that. You could actually get on a mobile device and see, when you didn't have the debugging tools back like 2 years ago, you could actually hack into the browser and just get some debug output as well. And they didn't do that, obviously. So that's native compared against web. As soon as you put PhoneGap into the mix, you're a native application and a web application at the same time. So you're kind of getting best of both worlds. With PhoneGap, there's one really big promise in the room, that is build once, wrap it with PhoneGap, and run it anywhere. And running it anywhere really means running it anywhere, across all those different platforms. iOS, Android, BlackBerry, WebOS, Symbian, Bada, Tizen, and so on and so forth. You're getting a consistent API for accessing all the device features. So it's going to be the same JavaScript for reading the camera, for instance. So this is what PhoneGap tries to solve. On the other hand, if you want to write really good and fast applications, you should be looking into an optimizer compiler for mobile, because on mobile we care deeply about performance. Because on mobile we got those slow CPUs, we do have those bad or old network connections, and we're running on batteries. So even if we were getting faster CPUs, we still can't really use them. We're just going to end up draining the user's battery. Well, and this is why Gwt is an excellent fit for writing mobile applications, because the Gwt compiler helps you a lot, and it's been doing that for several years, and this is just out there and you can just leverage that. The only problem today, if you want to write phone applications using Gwt, there's some key parts missing. They're missing good mobile widgets, that's what Mgwt is about, and Gwt PhoneGap is about accessing the PhoneGap API directly from Gwt. Both projects are under Apache 2.0, you can just use them. And they're a really cool way of writing HTML5 applications, which you can just take and deploy to any app store, or just put them on a web server as well. So cranky users like me who want to have a web application can just have that. And other people want to have different things can have that as well. You can do that from the same code base. So let's drill into the actual technology stack behind that. So if you're going to do a web application, basically you have the device, you have the browser, you're going to use some Mgwt for driving the UI, and some code on top of that. More interesting is if you want to write an actual application that's deployed into a web store, into an app store. You're going to add PhoneGap on the left. And PhoneGap already has a native part, and it has a JavaScript part, and on top of that you're going to need Gwt PhoneGap for actually communicating with the JavaScript underneath. So let's actually go into how PhoneGap works. So every PhoneGap application, I said that before, has a web part and has a native part. So on the website, there's the so-called native web control, and that's just a container for your HTML, CSS, and JavaScript. On the native side, there are so-called PhoneGap plugins. Don't confuse them with browser plugins. They're just called plugins. They don't have anything to do with browser plugins. Basically, those are building up the PhoneGap API. In between, there's something called the foreign function interface, which is basically a really clever hack in making the two speak to each other. So let's drill into all of them one by one. So browsers, well, in PhoneGap, the native web control is just a browser with no Chrome to the browser, and on different platforms, it's going to always be the platform browser. So on iOS, it's WebKit. On Android, it's WebKit. On BlackBerry, it's WebKit. On WebOS, it's WebKit. On Symbian, it's WebKit. There's just one company here. Well, let's actually take a look at the foreign function interface and how that works, because this is quite interesting. It works a little bit different on every platform, depending on what can be done, performed on any platform. This is like an example that's like 3 years old now. This is how it used to work on an iPhone. It changes a bit over time with the SDK. But if you want to write a PhoneGap plugin yourself, you might be interested in how that works internally. Let's say you want to take a picture. You can't do that as a web application. But as soon as you include the PhoneGap.js or the Cordova.js file, you get a camera object, on your navigator object, now you can say something like navigator.camera.getPicture. You're going to pass in 2 callbacks, one if it succeeds taking the picture, one if it fails, and some options, the quality of the picture, for instance. Internally, PhoneGap resolves that to the plugin, com.phonegap.camera, just a string, and the action on the plugin getPicture and puts the options into an array of options. And then it starts to build up an URL. URL starts with gap. This is different on every platform. On Android, they actually have a web server running that does the HTTP callback to the native code, but this is how it used to work on iOS. So they build up a URL. It starts with gap to make it clear that it's not an actual HTTP URL. Then there's the plugin. Then there's the so-called callback ID. This one is quite important. And then there are the options URL encoded. So now it takes that URL and puts that into a hidden iframe, which from a web developer's perspective doesn't make any sense whatsoever. But as soon as you do that, the native site which hosts the web control actually sees that navigation and the URL and just cancels that navigation. But now it can see the URL and can actually invoke the camera plugin and do what you asked it to do and return some data. Your actual callbacks, the success and the failed callback, are actually stored in JavaScript. And when the native site calls back with PhoneGap calls callback success, it actually retrieves your callback there and calls the right JavaScript function. So this is a very basic concept. This is why Apple never actually tried to ban PhoneGap applications out of the store, because if they were to try to do that, they had to ban every application that wants to display some HTML. So Steve couldn't do anything about it, and I think that's pretty cool. So you have to keep 2 things in mind. It's obviously encoding data, URL encoded, putting that onto a URL isn't the fastest way of exchanging data, of course. So let's say if you want to upload a file, you should be uploading the file in native and just display dispatch progress to the web view. And of course, you should be building asynchronous methods, because with that approach, you can't do synchronous calls. That said, on many implementations on PhoneGap, you can actually do synchronous calls because they use a different approach. This is like the most basic approach you could do. And this is why PhoneGap runs on every platform, because this is like getting navigation to know inside a native web control is really easy. We ported that even into Outlook, that same approach. So we got the native web controller, we got the foreign function interface, and now we have the PhoneGap plugins. And PhoneGap plugins are just native code. So this is just a normal native applications. But the good news here is that almost anything you're going to need is already there inside the Cordova or PhoneGap project. But if you need something that's not in there, you can just write your own plugin using the same API. There's a really good guide on how to do that. It's going to take you a couple of minutes if you're familiar with Android or iOS. So, but before you start building anything, there's a really good repository on high quality plugins out there. So say if you want to compose an SMS, write emails, or something else, you can just use those plugins as well. What I really like about PhoneGap is how PhoneGap thinks of itself as an open source project. And this is something, I think this is something unique to PhoneGap, because they think of themselves as something that has to die, something that has to go away once the browser is capable enough. So every time they actually added an API to the PhoneGap spec, they actually taking a look at the W3C spec and try to mimic their upcoming APIs. A good example of this is how they actually added a geolocation support to the iPhone. They did that the same way the W3C spec was reading. So they added that in, I think, 4 years back now. And once Apple added that with iOS 4, they could just remove the implementation, and you didn't need to do anything to your code because Apple had just implemented the same API. And PhoneGap thinks of itself as intermediate, as something that has to go away once the browser can do anything. And they've been so successful at it that they're actually being asked to test out new APIs from the W3C as well. So with a PhoneGap application, you can think of PhoneGap as a time machine for web developers. We can do all the cool things now that native developers can do as well, but we can do them on web standards. It's something that's going to be available to browsers in the upcoming years. This is how an actual hello world looks in PhoneGap. So you're going to have a script tag including the API. Then you're going to listen for a device ready event that tells you where the native code is ready for some calls. And then you can do something like, you could use just the code from the camera there, say navigator.camera.getPicture, put that in there, which just work. Some confusion about the name, PhoneGap and Cordova. This started out as the PhoneGap project, and it was bought by Adobe almost 12 months ago. It was a small Canadian company, and they were quite cool guys. They had a big community at that point, so they completely open sourced that and put that out to the Apache Software Foundation, and that's Cordova. But everybody's still referring to it as PhoneGap, so it's kind of exchangeable. Actually, Adobe is building up a suite of tools around PhoneGap with, I don't know, Photoshop and everything. So you can probably take some Photoshop or Dreamweaver stuff and shove that directly into the Apple App Store. They actually have a cool build system where you can just give them your JavaScript, HTML, and CSS, and they will actually give you the APK and IPK files back. So they're building tools around, and that's awesome. More PhoneGap, that's their branding name. But for us, that's Cordova is the real project. That's the real deal.
So there's not, it's not like Adobe forked it or anything like that?
No, they actually hired the whole PhoneGap team.
Okay.
But PhoneGap is not just funded by those guys anymore. There's actually someone from Google is directly working on it as well. Lots of people from BlackBerry. And the new BlackBerry is actually shipping a complete PhoneGap runtime directly inside their operating system. Because I think they figured if we actually do that, we can take all those applications that have been developed with PhoneGap and just execute them on our devices as well. So we have a start of, I don't know, 1 million applications. It's quite huge, the PhoneGap ecosystem. I think we can mostly skip through the Mgwt things here. Well, performance is really good at the Mgwt compiler because it does lots of crazy things, especially deferred binding. We're going to come back to that. Performance is critical on mobile, and this is why we need the Mgwt compiler in there to actually get those 10–20% over other frameworks. So Mgwt PhoneGap, I'm going to skim through them really quickly. It just gives you access to all the hardware features in there. So if you want to do something with geolocation, it's going to feel like a Java API. That's just, you're just going to say PhoneGap.getDevice.getName, something like that, or PhoneGap.getGeolocation.getWatch current location. And you can do that directly from Java. The cool thing is we're just using deferred binding, so you can actually develop your application inside the browser, and we just emulate the whole API for you. So, but since this is done by deferred binding, there is no runtime penalty to it. So if you're on an actual device, it was just take another permutation there.
So it's not like a wrapper for PhoneGap JavaScript API?
It's a wrapper for phone. It's a wrapper, but it adds emulation on top of that as well.
Could that not be eliminated for Android or?
Certainly, we could think about doing something in that area. Yeah. Okay. Well, let's talk about Mgwt. There's so much stuff in Mgwt, I can't possibly cover that in 20–25 minutes. There's touch support, different mobile widgets, editor support, UI binder, really fast and slick animation, multiple themes, and so on and so forth. It supports all the important mobile browsers. Notice there's no Windows Phone support. People are actually asking for that, but I can't really see any real Windows Phone usage up to that point.
All 5 of them?
Yeah, 5 people, I guess. So this would be adding Windows Phone 8 support to Mgwt would take like a day of work, I guess, because they're finally supporting the flexible box model as well. But I'm not willing to put in that day until we actually see some real usage of those phones. So this is how a Mgwt application, if you don't do anything to it, looks on an iPhone. Just like an iPhone application should look like, with buttons and elements on there. So I'm just going to skim real through the progress bars in there, different pop-ups. So we're just trying to mimic the native behavior, but we do that using CSS resources, so you can completely customize that. And I've done a lot of applications which don't look like standard applications at all. They just look like different customers wanted them to look like.
It seems like there was a lot of, JavaScript frameworks out there that were trying to emulate that look and feel. Did you like use one of those as a starting point, or is it all custom?
Well,
For the most
I
part?
didn't find any framework that was actually doing a good job at that.
Fair enough.
So I figured I need to do that from the ground up. So
Cool.
I'm gonna dig in that in a moment. So if you take the same application and start that up on an iPad, this is what it looks like on an iPad. So more grayish, I guess, and it's just lay out a little bit differently because you're gonna have more space. This is actually just 2 MVPs running there, so you can almost take like the same code for the tablet, desktop, and phone version and just arrange them a little bit different. So there are lots of different widgets in there that look like native widgets. So most of the times you can't really distinguish between a native application and a Mgwt application running on an iPad. So that gets really cool when you get to the next platform, because then you can just style it to look, well, like an Android application should look like, with different elements in there as well.
So this is all of the same code?
This is completely the same code. I'm going to dig into that in a minute, how this is actually implemented, but this is the same code base, it's just a difference in CSS. So there's so much stuff in there, and we don't have any chance to actually go in there, but what I want to highlight is performance, because performance is really critical on mobile. And people actually think that mobile applications have to feel sluggish or bad if they're done in HTML5. And Facebook actually went off from HTML5 to native to get a better performance. And I think they did a really poor job at this. So if we look at performance, there are different ways of performance. There's startup performance, there's runtime performance, and there's resource usage. So let's drill first into startup performance. So startup performance mostly drills down to download, evaluate, and execute. The bad thing is you have to download every file, and you're getting latency and transfer time for every file. And that's quite important on mobile, because on mobile, well, bigger is not always better. We do have really bad network connections on mobile, so you have to do all those things just right to get a mobile application really running greatly. So you have to think about your overall size. You have to do HTTP requests, and you have to do async loading, HTTP headers, right? Caching, offline support. You need to batch your data calls. You need to minification of JavaScript and CSS. You need to be thinking about spriting and inlining. You should be doing gzip transfer of your resources. And you should be thinking hard about code splitting. Can I actually get the first few screens down and do the rest? As it turns out, this is a list of what Mgwt is really good at. The other thing is you have to think about parsing. You have to actually parse your JavaScript, your CSS, and the HTML as well. And then before you can actually see something, the browser has to take the DOM and the CSS tree, merge them into the render tree, lay out that render tree, and bring that to the screen. So you want to be concerned about DOM size in CSS as well. So, and if you normally go into a JavaScript library, you're going to put in some JavaScript library, some CSS, then you're going to add some JavaScript on top of that, some markup, some CSS, and some resources. And after a while, you're going to discover this is really getting slow, and I need to optimize in some way here. And then people actually try to do that by hand, by iterating through that stuff. And as it turns out, this is a really hard job in getting something like this fast. So this is why most websites, if you take a look at the top 100 mobile sites, are really bad at this. Most of the things I just mentioned on that slide where Mgwt is good, they don't do that. So you want to be looking into an optimizing compiler that got all those best practices built into it. So you don't have to mess with all the messy details around. Like doing manual code splitting in JavaScript, that's a really hard job. If the compiler can do that for you, that's much better. So we don't do something like that in Mgwt, of course. We just have CSS resources, we have Java code, and we have some other resources. But the compiler knows all about them, just spits out some Mgwt output. And on that, with the old mechanism, we can actually have perfect caching. We can do code splitting. Just split the application up and have a few kilobytes of initial download there. That's going to render the first screen. But as it turns out, all those phones, because they do have slow CPUs, do have really up-to-date browsers to make up for it. So they all are capable of actually storing your application locally on the phone using app cache. But people are actually writing articles on how hard it is to use app cache. And with Gwt, again, that's really straightforward because the Gwt compiler knows all about your resources. We can just use a custom linker and write the manifest file for you. And then we got no download at all. We're just going to download the application once, and if it's in sync, we always start that up locally. And that's like 1,000 times better than the other frameworks. And we don't need to actually mess with that to get that done. So remember, bigger is not always better. There are mobile JavaScript frameworks out there where the library has about 200, 300 kilobytes of source code. And if you think of a bad network connection, like 4 kilobytes a second, imagine how long the start of such an application will be. No one's going to wait for a minute for that to load. So you need to be really careful of what you're going to do on mobile. And if you take a look at Mgwt, it's really, really small. Like the worst case, the showcase, where every widget is in there once, so the Gwt compiler actually has to put every widget and every CSS file in there, that's about 250 kilobytes. But that's like the worst case.
There are other worst cases we could show you, but yeah, anyway.
But the normal Mgwt application that uses like 20–30% of Mgwt ends up being about 50 kilobytes. And then we can actually do code splitting for the first screen, and we're going to end up being around 4 kilobytes to render the first screen. So even on a really bad network connection, we can boot up in a second. I used to have a slide actually comparing Sencha Touch and jQuery Mobile. And I did post that a lot, so they actually optimized on it, so they're getting better. But as it turned out, 2 years ago, they were at codes for the initial rendering. They were at a code size download of 900 kilobytes. So no way to do that on an edge connection. And jQuery Mobile was somewhere in the same order of magnitude, 500 kilobytes. At the same time, we were running around sometimes even smaller than 1 TCP packet. So this is where we can actually get using the Gwt compiler. But you actually have to do some good choices in the library to stay small. So I want to highlight some of those choices. In that screenshot, there's no image. None whatsoever. This is just done with CSS, and that's possible because, again, those browsers are really up to date. Even the pointy stuff of the back button there, that's just a div turned with a background there. Even the slider there, no. And the other thing is, no images there. Imagine the difference between downloading a background of a few kilobytes between having a small CSS string that's in the bytes. So with CSS3, that's really easy. The other thing you want to have a minimal DOM, because then the matching between the CSS and your DOM is going to be fast, and you don't need to lay out so many elements inside the render tree. So this is actually one of the worst case widgets in Mgwt. It's got 3 DOM elements. That's the slider there. That's like the background, the slider bar, and that pointy thing there. We could probably optimize one out of there, but normally you don't put like 100 sliders in your application, so I didn't do that. But as it turns out with Gwt, we can actually help on the matching process for the CSS selectors as well, because CSS resources can actually make them unique, and so we don't need to nest them deeply. So we get a good selector performance as well when it comes to matching. And actually, this is taken from a really big Mgwt application, as you can tell, because the selectors are getting really long. Normally, we just start off with a 0 prefix on the selectors. But the most important thing that Gwt can actually do for us is that code removal. No, it's not going to. Probably the image is just too large, and I don't know. Yeah, there it is. So this is what you're getting at. So those 2 sliders, this is the Android one, and the other one is the iOS one. They actually share a lot of code for moving that slider around, but they don't share so much code in their styling. So because we compile once per device, we can actually have a small add-if in the CSS resource and have different style routes for Android, Android tablets, iPad, and so on and so forth. So this compile, yeah, let's quickly go into that one. So this is how you actually do a background these days if you want to do that cross-browser compatible. And this is one of the things I said when I joined the Gwt team. We actually need to do something about the parser, because currently you actually have to go at Firefox do this, at IE do this, so you have to split them up manually. Well, what I want to see in Gwt is actually us having the, let's say the background linear gradient, and then split out all the others inside the CSS parser.
CSS has
Yeah. But normal frameworks like jQuery, they actually send that down to the client. So lots of unnecessary bytes in there. So we can split that up just fine. Today we have to do that manually inside the Mgwt compiler, but this is not a hard job to actually fix that. So we have to do that. The Mgwt compiler can actually do things like if you write background blue and background red on the same, so that you can just remove that as well. And this is why Mgwt chooses to not use CSS resources. We just use CSS resources from the start, and people actually complained about that because they thought CSS resources are really hard to use. And why should we be using them if you could just type normal CSS? But the gain and what you're going to be able to optimize out on these CSS is so large that you can't really do serious mobile applications without using CSS resources. So there are different standard themes in there. There's an iPhone, iPad, Android phone, and a tablet, BlackBerry, and a desktop theme. There are a couple of other people who actually develop themes as a Java you can just throw in. And the good news is there's also a project which you can just clone and which got all the CSS resources with empty selectors. You can just add your styles as well. Something about mobile performance. I think we got everything just right in Mgwt, because if you have a really large application, you manage to download the whole application. This is what you need to do. You need to do parsing, executing, and rendering. And this is a comparison. This is about a year old between an iPhone 4S and an Nexus S. So you can see parsing is really good for an Android application. This runs about 20 to 30 milliseconds. Then there's actually executing the JavaScript, doing something to it. This runs at about 70 milliseconds. And after we've set up the DOM and everything is done, the browser still needs about 200 milliseconds to actually get that painted on the screen. So in terms of performance, if we want to get that faster, we actually have to take into account how to make the browser faster painting. Because we do have a minimal DOM, we do have really good CSS selectors.
And you have an appointment.
Yeah. Bashka made me do that. So in terms of performance, it's pretty important that we actually take a look at how to make the painting faster on mobile browsers. This is where you can actually feel the limitation of the CPU and the GPU on a mobile browser. Let's quickly, how am I doing on time?
10 minutes, 35.
Okay, that should be enough. Let's quickly do into runtime performance. And the not so obvious but really important thing on runtime performance is layout performance. Because if you're going to have a bad layout performance, something's going to happen like this. You're going to move your finger on the display and the app is lagging behind. It feels sluggish. That's what people actually expect of HTML5 applications on a phone, that they feel sluggish. They don't feel like native applications. So this is how people actually try to do, in most frameworks, layout for their applications. So they have a resize listener somewhere in JavaScript. If that fires, they recalculate the size of the DOM, update the DOM, and then this is going to trigger a layout and we're going to see something. The problem with that is most of the stuff is actually running inside the JavaScript VM, which is really slow compared to what you could actually be doing. If you want to have really fast layout, you should be never leaving native code. This is a very strange statement to make as a web developer because we're never writing native code. Well, in a way we are. The CSS we are writing is executed directly by the layout engine, which is written in C or C++. So we can actually configure the layout engine to do most of the work for us. And as it turns out, again, with HTML5 and those modern browsers, I'm going to skip this one, we can actually do that using the flexible box model. So if you don't know the flexible box model, this is a great time to actually read up on it because IE10 already implements that as well. With IE9, they went like, hey, we know something better from Silverlight, we're going to implement that, and everyone else was doing the flexible box model, so they finally botched in as well. So this is usable across a vast majority of browsers.
One thing I don't understand is this size is going to be for mobile application. Why? Because, I mean, only used to be laying out one application.
Yeah, well, if you turn the phone, you got to do a relay out, of course.
Oh,
Yeah,
Plus, the framework likes desktop metaphors of having active layout, of choosing where to put all the pieces.
you don't want to be doing that. You want to just be you just want to be doing layout. Oh, I don't have the slides with me. I'm sorry. I just wanted to go into a few details on flexible box model. So with the flexible box model, you could say you could have a container and actually say take up the rest of the space, or be centered. So with the flexible box model, you could be doing everything you wanted to have in CSS for like the last 10 years. So you can just have 3 divs and say this one got this width, and the other one is just going to take up the rest of the space. And if you think about most of the layouts, that's absolutely sufficient. And I can show you real quick, if you got time for that, how it actually looks on the phone, the difference between an application that's done with the flexible box model and can be laid out directly with the layout engine, and an application that isn't done that way. So basically, if you turn the phone, you can see an Mgwt application layouting while turning. It's already done when the phone is turned. And if it's done the wrong way, you can actually see the phone turning. After that, the resize listener fires, and then you can see the phone starting to do some calculations and updating the screen. And this is one of the main reasons that it actually feels sluggish. If you're not going to do the whole rendering thing in the layout engine, this is going to be sluggish. If you're doing that, it's going to feel perfectly fine.
So you shouldn't use Gwt layout panels?
No, you shouldn't. On mobile, you shouldn't be using Gwt layout panels.
Screens also using CSS.
Not yet.
Yeah, some of them, basically they use something like position absolute, and they do top left 0 and bottom right 0.
The absolute layout panels were designed by Joe Weber, again, to address the IE6
Yeah.
code enter. And nowadays, if we were designing them from scratch and you had flexible box model, you probably would base the absolute layout panel on like flexible box model.
Yeah, I wouldn't use the layout panels like Gwt has currently on mobile because they just have way too many DOM elements. You can have that with one DOM element and the flexible box model. If you want to make that work on IE6, of course, there's no way to actually do that. You have to have all that boilerplate around, but you don't want to have that on a mobile browser. I don't know if you can actually take a look into the layout panels in Gwt and actually make a deferred binding to make them much better on a capable browser than you can actually do on it.
You can, you'd have to add more permutations to differentiate them.
Maybe. So let's talk quickly about animations. Some frameworks actually do animations by setting up a loop, a timer in JavaScript. And let's say you want to move a div from here to there. And so basically what they're doing is telling the browser, move it 1 pixel, move it 1 pixel, move it 1 pixel. So the only thing the browser can actually do is update the DOM, update the render tree, lay out that, and print that through the screen. And that's really expensive. You don't want to do that. So actually, you should be telling the browser, I want to move that div from here to there in 300 milliseconds with a certain timing curve. And what happens then is the browser actually paints an image of the region you want to move, uploads that to the GPU, and the GPU executes that animation for you. So without any CPU consumption whatsoever. So this means actually we can do animations that are as fast as native animations inside the browser. So basically how this is going to work, you're going to put some dynamically created CSS for that animation to the DOM, and after that the browser actually figures out how to do that efficiently. And as it turns out, if you actually profile that, at least on an iOS device, this is the same Objective-C routine running that we would be animating natively. So this has the same performance. So if you take a progress bar, an Mgwt progress bar, and put your iPhone on the table, just sitting there, letting it do the animation, it won't drain the battery. It's really efficient. So this is basic things about runtime performance. So we started actually out with the web and all the possibilities on the web. And I'm thinking that the things we're going to do with our phones all around us is simply going to explode like the amount of web pages in the late 90s, which founded Google. So we've seen that on the web, and we actually just want to build things once. We don't want to build them all over the place for Android phones, for Apple, for I don't know who's going to come next, Windows Phone, BlackBerry. And PhoneGraph is a really good answer to this. Because what PhoneGraph enables us to do is to use HTML5 standards and let our web applications run everywhere. And if you're concerned about performance, you should certainly be looking into using the Mgwt compiler for the actual UI, because the Mgwt compiler is really good at this. Right now, there are few issues with the Mgwt compiler. At some points, where it could actually be much better. But most of the times, we are actually better than most of the other guys out there. And if you want to take a look into that, you should be looking at Mgwt and Mgwt PhoneGap as well, because they look really good, I think. They're really performant, because they're made with performance from the ground up. We wanted to do something that was at least as good as native applications. And that's about it. How are we doing on time?
Pretty good.
Pretty good. So let me do one more thing. Can I actually plug in a phone?
You can hold it up in front of the camera.
Actually, I got to connect to produce VGA output.
Oh, you should be able to do VGA.
Oh, we used to be able to.
No, that's the local connection. The recording.
They redid the whole conferencing system.
Yeah, when they do the
Yeah,
recording,
but
they
I
don't
thought
allow
GDC supported VGA input.
Well, no, not when they're doing the recording.
Okay.
Can we just throw that up the screen there?
You can like that's the
hold it up
camera
in front of the
there.
camera.
That's not going to work.
Yeah. If you don't have to, it's already.
It doesn't get recorded. It's not that bad. Let's just put that on.
We can record it from that camera, but it'll be like.
I don't know. That's not. Let's just throw it up with a VGA connector.
I don't
No,
know
the VGA doesn't work.
Google like got rid of all of those. So, like, now everything is down Hangouts.
No, actually, when you're recording it, the VGA doesn't work. Otherwise, you actually have a local option.
So let me.
Oh,
you
there's
don't have
still one there.
No, it's not. Not
Is that
when you're recording
Is
it.
that viewable at all?
Yeah, it's blurry.
Yeah, it's,
Okay.
it's okay. Yeah.
So I'll have to exit you from the thing.
So this is actually the Mgwt
Just
showcase.
select
If you go to
the-
m-gwt.com, then you click on showcase. This is what you're going to see. This is just taken and put on the home screen.
I'm gonna have to get rid of your.
Wow.
Wait, Daniel, we have to wait for. I want to get rid of your GVC first here. Otherwise, it doesn't.
Oh, that's fine. Yeah. Yeah, this is
It's
focused.
really hard to hold up.
I can help
I
you.
want to get rid of this first. Otherwise,
Yes.
it won't record. It'll
I could
record
try
this
to
thing.
keep moving.
I have taken it
No,
down.
you
So
go out and then share
we're
it.
moving
I
down.
want to log out of the
I
sharing.
moved it down.
Can you just log out of? I don't know which one is
Touch
the.
screen sharing.
Yeah. One of them will eventually be the right one.
Okay, you got rid of that. Okay. So now it'll record that one. Yeah.
Yes, I will help. Do you want me to zoom?
There you go.
Okay.
It's all backwards.
Okay, so this is the actual Android showcase. If you take your phone and actually point it, if you've got an Android phone, it's going to look like an Android application. If you got an iPhone, it's going to look like an iPhone application. There are some cool animations in there that just give you an idea what you could be done with CSS. And you wouldn't guess that this is actually not a native animation running there. This is just this web application. And there are lots of different, I don't want to drill into every one, but there are lots of different widgets in there. They behave like native widgets would behave. Really performant and really slick. I mean, which one is a good example? Carousel is a good example. You've got lots of different scroll plans where you can just go through and scroll there. You should try it for yourself so you get a good idea. The cool thing you can actually do, you can take such an application and put that inside a PhoneGap container. So this is a PhoneGap, this is a Mgwt application running inside a PhoneGap container. This is just a demo application that basically shows you how to access native APIs. So this is reading the accelerometer while I'm playing around with the phone. But what you can actually do is read the camera that we had on the slides. So this is still a Mgwt view, and if I press on this button, a native view is going to pop up and actually display the camera. Just like this. I can actually take a photo. It's a German phone, so this means actually use the photo. So just click here and say use the photo, now we get the photo inside there. So this is how you can integrate with device APIs. So your users won't even notice that you're not a native application. So, any questions? Sound is also possible.
Video.
You actually access the contents of the iTunes library, or do you have to write a plugin for that?
You can just access the contents of the iTunes library just fine. Like you can do anything a native application can do. So if it's not there, you're just gonna write the native code yourself. So geolocation, file system, everything's gonna be there. Okay. Any questions?
I bought.
So I had a question. So you're saying people don't want to do apps, they'd rather go to the browser, but what about security? Right? You don't want to keep going to websites and access your capabilities of your phone, right? So how is that going to work?
Yeah, well,
longer term?
Is that any less than downloading code from?
Well, if you
some
download
other
an
site?
app, then at least on the Android phone, it tells you what that can access.
Yeah, but people like security fatigue, right? People mostly don't read those permissions, and for some things, permissions didn't even exist. Remember, there's a scandal with Path and a bunch of these other companies where people were installing apps on their iPhone, and it was basically getting your phone number and address book and just uploading them to the server, and no one even knew. And so,
That's what.
well, the web
But
is
if it's a
better
web
that way.
page, then it can be even more.
Yeah, well, the browser's going to ask you, do you really want that application to access to your video camera?
Instant messaging applications.
And if you're at a point where you think, why would that application would like to access my video camera, you're just going to say no. And eventually this is going to cause an overhaul of users because you don't want to be asked, do you really want to use the mic, do you really want to use the webcam, do you really want to use it, and so on and so forth. So we actually have to figure out a better way of doing that inside the browser.
but in general,
There's a working group
yeah,
at the W3C that does
yeah, the
exactly
device
that.
capabilities. But in general, the browser people have been far more careful about that kind of stuff than the native APIs. Like for example, just the full screen API and the mouse capture API, they went for months and months refining that to make sure that there was no way to click jack somebody or to full screen something and take over the whole browser screen in a way that would, because people have done this with Flash, where basically they would literally take over your entire monitor, browse that, and then basically and they'd emulate the desktop. So like they assume you're on Windows, and they'd make a complete like Windows XP desktop, but it was a fake one, and they'd pop up like some kind of dialog box like you need to log in, and they get their username and password and things like that. So to make sure people aren't phished or clickjacked, the web people I think have done a far better job looking at security than like the iOS like native stuff.
It's also better. I mean, with an Android app, it asks you up front, and you don't even know why it's asking.
Yeah, that's
Yeah,
the point.
and there's no granularity. Like a lot of times, I'd like to say, okay, I'll use this app. I don't want to allow this permission, and
It's the usual
just
thing.
disable whatever features
Yeah.
need.
And the permissions are usually so generic. Sometimes it's like request access to all websites on your or all this on your phone, right? Or like Chrome permissions do this too. It's like if something wants to install a Chrome extension and actually get access to like the history, like the current URL or whatever, basically the permission is basically requests access to all websites, basically. And what's a user to do when they install that, right? They are not going to have any clue as to like what that means. So it's a problem in general, I think. But I think it's probably safe to say that the native apps don't really are not really any more secure. I mean, people have done there's a lot of malware in like the Android store, and there's a lot of stuff in the iOS store that's been raping people's personal info and uploading it.
Right, but then they actually ban some of those things. Right?
It is true that they have a way of curating things that we don't have in the web world, right? I think that there's
Right. So in the web
good
world,
things about that and there's bad things about that.
Right. Okay, we have more questions.
Yeah, so what about the background? Like, if you have some background task in your application, you really have to write an plugin or extension for.
So you're thinking about web workers. So you want to do something.
Like when you really want to run your application when it's not in the foreground.
Okay, so if you don't have the browser running, well, you're going to resort to using the native SDK at that point. Say you're going to run some code in there.
You can't even do it on iOS, by the way. Like on Android, you can get away with running like background.
There are some
services.
stuff like location you can access.
Yeah, but it's like it's like scoped down, right?
Yeah,
Like,
yeah.
Even like with notifications and things like that, it's severely limited. Like you can get a notification that you got a new email or you got a new chat message, but actually when it's only basically a little bit of a string data that comes in, and when you actually click it, it actually then wakes the app up and goes to the server, makes another HTTP request, and re-requests the same thing, because the actual iOS background for notifications doesn't actually allow you to run your app during the background event.
But if you think about a phone web application, all the same restriction that a native application has just applied. So anything a native application can do right away. Well, the only thing you have to get your hands dirty at some point if it's not in a standard PhoneGap API. But the way you actually exchange data, there's this PhoneGap.exec. Today it's called Cordova.exec. You're going to be transferring the data the same way. You're going to name a plugin, your old plugin, and the action on the plugin, and just that data is going to flow in. And then on Android, it looks like a JSON array coming in with an execute method on this.
But I think
side.
presumably, right, if someone wanted to write, let's say, an Android service that ran in the background persistently, they certainly could make a plugin for PhoneGap that does that, installs the service, launches it, and they use some intent in Android to basically talk to it from the PhoneGap thread in the browser, and you could basically get. I don't know what the equivalent on iOS would be because they don't have intents, but presumably it's a similar thing could be done.
Okay, so I think we're over our time. So thanks, Daniel. Mary's going to take. Who wants